My name is Vladimir Horkov, and this is the CQRS in Practice course. In this module, we will talk about some of the best practices and common misconceptions around the CQRS pattern. We have come a long way refactoring our application to follow the CQRS pattern. Let's reiterate some of the best practices and misconceptions we encountered along the way, as well as discuss some that we haven't yet talked about. The first one is the relation between CQRS and event sourcing. CQRS is often described as stepping stone to event sourcing. In other words, it's described as just a transition stage that eventually leads to event-sourced architecture. It is not the case. CQRS can be applied on its own and may provide a lot of benefits to the project even if you never implement event sourcing. Even more, event sourcing brings a lot of complexity to the table, and the bar for it is much higher than it is for CQRS. Even higher than for the separation at the database level that we discussed in the two previous modules. Having that said, there's still a lot of value in event-sourced systems too. It's just the complexity overhead is not as often justified as for CQRS. Usually the applications that benefit from event sourcing, despite all that complexity, are a special kind of systems. Those for which it is essential to keep track of the events that led to a particular state. For example, pretty much everything in the finance tech area would benefit from event sourcing. In such systems, you must provide an audit log, a trail of all the financial transactions, and so treating domain events as the first-class citizens makes a lot of sense here. So CQRS can be applied on its own with great success, independently from event sourcing. These two concepts are mostly orthogonal to each other, mostly but not completely. You don't need event sourcing to implement CQRS, but you do usually need CQRS to implement event sourcing. Event sourcing without CQRS, without separating reads and writes, is a less common and less scalable solution. In theory, you could do that, but I've yet to see it being implemented in practice. We've discussed the evolutionary approach previously in the course, but let's reiterate it once again, as it's quite an important concept. You don't have to implement all the techniques from this course. Do not just throw every related CQRS concept at your application. Defer these decisions until you have proven their need. And by the way, that's the approach I recommend you take with any design pattern, not just CQRS. Remember, every design pattern has both costs and benefits attached to it, and you need to be sure that the benefits outweigh the costs before applying that pattern. Again, you don't need to apply all the techniques at once. Even with just the separation at the API level, with the task-based API alone, which we implemented first in this course, you will reap significant benefits. Note that CQRS is not an application-wide pattern, like the microservices architecture. Rather, it should be bound to a specific bounded context or microservice. It means that you can make different decisions in different bounded contexts when it comes to CQRS. Say, implement the full separation down to the data level in one bounded context because it is very important to the business and has high performance requirements. And at the same time, implement just the separation at the API level in another, not that important bounded context. Or even keep spaghetti code with giant CRUD-oriented endpoints. That could be an option too, depending on your project circumstances. However, in the vast majority of the enterprise-level applications, the sweet spot is the separation down to the domain model level. The separation of everything except the database. That usually allows you to achieve the best balance between the costs and the benefits. There is another question that we discussed throughout this course and which merits reiteration. And that is, can you use other commands and queries from your command and query handlers? The short answer is no, but the long answer actually differs depending on the situation. There are quite a few permutations in this question, so let's tackle them one by one. First, can you use another command from a command handler? Here's the example I brought up in an earlier module, with disenrolling the student from the existing courses before unregistering them. You can see we are instantiating two disenroll commands and dispatching them using the message dispatcher. It's tempting to do that, but it is contrary to the very notion of commands. It is the client that triggers commands, not our system. Our system reacts to those commands and produces domain events. It cannot create subsequent commands on its own. If you need to reuse some code between command handlers, extract it into a separate class, such as a domain service. Don't reuse command handlers themselves. Here's a picture that will help clarify the relationships between our application, the client, and the types of messages they exchange with each other. As you can see, the client sees the current state of the application and produces a command. The write model receives the command and produces events. The other side of our application, the read side, receives those events and uses them to build up the snapshot of the current state. That state is what then shown to the client. This is the circulation of the messages and the state in the application ecosystem. A command is a representation of what the clients can do with the application, and only the client can raise them. An event is a representation of what has happened to the application. And finally, the state is the sum of all the events we've had up to this moment. Next, can you use a query from a command handler? Here, the answer depends on whether or not you can have a reliable way to request the current state in the command side. If you do, then no need to use a query. Just refer to the command's database directly to retrieve the piece of data the command needs. If there is no reliable way to request the current state, then you don't have any choice other than using a query from a command handler. For example, if you have implemented event sourcing, then the commands cannot request the current state from its own database with a reasonable performance, because rebuilding that state out of events every time you need to know something is not practical. So you need to use the read database, and you need to do that via a query. Note that in this case, there is a whole set of issues that come into play because the read and the write databases are not immediately consistent. For example, unique constraint validations might not be done because of that. Note that they only come into play if you are implementing event sourcing, and that's a story for another day. Finally, can you use a command or a query from a query handler? Well, the answer for commands is obviously no, because a query handler cannot mutate state. As for the use of another query from a query handler, the guidelines here are not as strict because the read model is immutable, and it's hard to mess up with it thanks to this fact. But in general, I would say don't reuse the query handlers either. Extract the command code out to some service and use that service instead. Another commonly held belief is that commands should always be unidirectional. In other words, that the commands should not return anything because that would violate the underlying CQRS principle, the command query separation principle. The approach that is suggested instead is to poll an external source for the command execution result. So when you, say, register a student, the command side shouldn't do that right away. It shouldn't provide you with results synchronously, but rather it should start executing the request asynchronously, and you need to poll a separate API endpoint to know the results. That is another misconception. Truly one-way commands are impossible. They always need to return some kind of acknowledgement, either an OK, an error, or a locator which you can use to poll the results from a separate API endpoint. And so, why return this locator if you can just return the results right away? If the operation is not inherently asynchronous and doesn't take much time to complete it synchronously and return an OK or a validation error. If it is an update of some entity, you can also return an aggregate's new version number. No reason to implement an overcomplicated flow of events where a simple synchronous execution would do just fine. It's also fine to return an ID of a newly created entity. This one looks like a true violation of the CQRS principle. After all, it looks like the command returns a genuine piece of data here. But no, it's not that. It's okay for commands to return a locator of the resources they create. And if you are creating the resource synchronously, then the ID of that resource would be this locator. Alright, this is a big one. There is a controversy between two domain-driven design patterns, CQRS and the specification pattern. By the way, I have a course about the specification pattern too. Highly recommend that you check it out. So the controversy between them is that these two patterns are incompatible. The specification pattern allows us to encapsulate a piece of domain knowledge into a single place and then reuse it in 3 scenarios: data retrieval, user input validation, and creation of a new object. We are currently interested in only 2 of these 3 scenarios. This is useful because it allows you to avoid the domain knowledge duplication. The same domain class here would be used for both validation of the incoming data and filtration of the data in the database before showing it to the user. At the same time, the CQRS pattern proposes the separation of the 2. Validation belongs to the command side because it precedes data mutation. You validate data before you change something. Whereas data retrieval belongs to the read side. It's what the client queries to see what data there is in our system. And so there is a clear contradiction here. On the one hand, the specification pattern advocates for having a single domain model for these 2 concerns. On the other, CQRS advocates for splitting the domain model into 2 and dealing with those concerns separately. So which one is that? That's a classic example of the contradiction between the DRY principle, which stands for don't repeat yourself, and the principle of loose coupling. And the guideline here is this: the loose coupling wins in the vast majority of cases, except for the simplest ones. Domain knowledge duplication is a lesser evil than the high coupling between the system components. When you duplicate the domain knowledge, it's not very convenient, but it's not that bad when you compare it to the alternative. With the high coupling, you're not able to do anything because your hands are tied by the restrictions posed to another component. And you saw this in our sample project too. Before we removed the domain model from the read side, we just couldn't implement an efficient querying mechanism, all because of the unified model for commands and queries. The specification pattern works well in simpler cases. However, in large systems, you almost always would prefer loose coupling over preventing the domain knowledge duplication between the reads and writes. Here are some useful links that I referred to in this course. The source code for this course is available on GitHub. It contains 2 folders with the initial and the final versions of our application. You can also look at the commit history to see what changes were done in each module. If you need an introductory course on the topic of domain-driven design, I recommend my Domain-Driven Design in Practice 1. This is the CQRS book written by Greg Young. This is the article where you can see how to use event listeners in Hibernate and the change tracker in Entity Framework to automatically raise the isSyncRequired flag in a separate table whenever you update an entity. You need section 7 in that article. And this is the article about how consistency is handled in the real world, using the Starbucks example. We've made great progress in this course. You have learned about the CQRS pattern and how to apply it in practice. The 3 goals of CQRS are simplicity, performance, and scalability, simplicity being the most important one. We gradually introduced more and more separation to our system. First, we separated our API endpoints and split the single giant update method into several task-based ones. That allowed us to transition away from the CRUD-based thinking and introduce a task-based interface, both the UI and the API. Next, we extracted explicit commands and queries and handlers for them out of our controller. That allowed us to introduce a unified .NET interface for the handlers and then create decorators to tackle cross-cutting concerns with a minimal amount of effort. After that, we extracted the domain model out of the read side, which allowed us to both simplify the domain model and write high-performance SQL queries for the read side. Next, we introduced the separation at the data level. We created a separate database for reads with a schema perfectly aligned with the needs of the read model. That allowed us to improve the performance, simplify the read model even further, and enable scalability on the query side. Finally, we discussed the synchronization between the read and write databases, and we also discussed best practices and common misconceptions around the CQRS pattern. Be sure to subscribe to my blog, where I will be putting announcements about more courses about domain-driven design. This is the short link for you to do that. Also, feel free to get in touch with me. Here are my email, Twitter handler, and blog. This is Vladimir Horikov. Thank you for listening.